Today, we will consider a very important organic reaction, rather rearrangement reaction, that is Beckmann rearrangement. So please get your pen and paper and let's begin. I'm sharing my whiteboard. Beckmann rearrangement is a very important name reaction which involves conversion of ketoxime to N-substituted amide in the presence of acid. So acid catalyzed conversion of ketoxime to N-substituted amide is Beckmann rearrangement. So you can have either of these reagents, that is H2SO4 or P2O5 or SOCl2 or PCl5 or C6H5SO2Cl2. SO2Cl. So either of these acids could be present. The examiner can, instead of H2SO4, examiner can give any of these acids and you have migration of, so let's see first what is the reaction. This is nothing but your ketoxime, right? C double bond N OH. NOH group is when attached to C double bond N group, that is ketoxime. Now H plus is your acid, it will give you amide. Very important conversion. Basically, it involves, the most important key point is it involves the migration of group from carbon to electron deficient nitrogen. How is that possible? We will see in the mechanism. And whatever migratory group is there, that should be anti. Means if you are speaking in this particular reaction, the migration that will occur, OH is here. So R dash is opposite or anti to the OH group. So that will only migrate. All these points will become clear when we study the mechanism. So let's begin the mechanism. I begin with R dash C double bond NOH. Let me write it properly. Right? So now H plus will go and attach to this OH group like this. This bond will be, so nitrogen is having its lone pair all the time. Okay. Even though if it is not written over here. And this will take off in order to remove this positive charge from oxygen. Oxygen is electronegative. So positive charge on oxygen is not preferable. So the reaction will proceed in such a way to remove this positive charge from oxygen. So in this case, we are left with R dash C, double bond N, lone pair is there, and positive charge will be left on nitrogen. Now, since OH group was opposite, so this group, that is R dash, will undergo migration to the electron deficient nitrogen, and we will be getting R C double bond N R dash, right? And now carbon becomes electron deficient, that is a carbocation is generated, then water molecule is added to it, and we will be getting nothing but your RCOH2 plus and double bond N R dash. So this can rearrange and give you the desired product. So it is as follows. Let me make space here. The desired product will be substituted. right? This is your amide. We begin with ketohexane and we end up with the amide. Now, if you were to ask about the applications, it has numerous applications and wide variety of organic compounds can be prepared. Like suppose I begin with this cyclohexanone. This is treated with ammonium hydroxide to obtain cyclohexanone oxime. This undergoes Beckmann rearrangement to give eta-caprolactam, which upon base, treatment with base and heat will give you a very important polymer, that is Perlon. Next, when we have benzyl aldoxime, okay, this one treatment with H2SO4, which is a dehydrating agent, will give you phenyl cyanide. Third example is cinnamaldehyde oxime, right? On treatment with phosphorus pentaoxide will give you this kind of a structure which will rearrange and give off water molecule. Memory technique I have written over here. Water molecule is eliminated like this to give you a very important natural product, that is isopinyl. So these are the three examples of Beckmann rearrangement, which proves that is a very, very important reaction, very, very important reagent, and not only from organic chemistry point of view, but also you can always find questions or these reagents in competitive exams where you have questions from the carbonyl group section. Thank you.